All right, so in this one, you ended up with 1.806 times 10 to the 24th. Did everybody put that in their calculator? Is that what you got? So how you're going to put this in, remember, and you can write to yourself like the note with this one. So just take 3 times 6.02 EE 23. Okay? So just write it under here. To do the math, it would be 3 times 6.02. Then you push the EE button and then the 23, not 24, and then equals. So that's kind of like the steps to solve. Can I keep that number? How many significant figures do I need? Only one, right? Because I have one significant figure here. So that means the 1, the next number is an 8. So what does that change it to? 2. So it'd be 2 times 10 to the 24th. I still keep times 10 to the 24th. So that doesn't get changed or rounded, just the numbers out front. So here's the one that's the real challenge. So this one, you want to go from molecules to moles. So in this, again, you don't have to figure out formula mass. You're just going to use Avogadro's number, but do make sure that you write it out. So 1.3 times 10 to the 21st molecules times in a line, what goes on the bottom, molecules, moles goes on top. So it's 6.02 times 10 to the 23rd on the bottom. So this one's the real challenge to see if you can put in the double exponents for this. So I got 0.00215946 moles. Everybody get that? That's a 2. 0.00215946. Anybody not get that? Okay. Okay, so I put in 1.3 EE 21. Then I did divided by 6.02 EE 23. What did you not do? Oh, yeah, that'll add a problem. Okay, so see, did you get that? Make sure you can put it in your calculator. That's really the reason why people get these ones wrong. It's because they don't know how to put the exponents in the calculator consistently. But remember that EE, that's actually times 10 to the, so it's actually putting your number in that exponent value. And the nice thing about the EE is it puts brackets around those exponents. So if you remember doing math, like with other calculators, you'd have to put those parentheses around anything with an exponent. If you use the EE, you don't. It automatically puts those parentheses in there for you. So that's one of the reasons why I kind of like it, is I think it makes it a little simpler.
And you use this formula when it says moles.
If you have molecules to moles or moles to molecules, then you're going to use Avogadro's number, right? So I kind of put it up at the top, that purple up at the top. If there's grams to moles or moles to grams, then I use the formula mass. But if molecules is one of the values in it, then I'm going to use Avogadro's number. Okay, so last question. I can't keep all these numbers, so what do I have to do? How many significant figures? 2, because see the 1.3 times 10 to the 21st, the 1.3, that's the 2 significant figures. So remember, you keep the zeros out front, but they're not significant. The first 2 significant figures I get to are the 2 and the 1. The next number is a 5, so what does that do? It's going to round it up. So this would be 1.0022. I keep those zeros out front because it shows the size of the number. But 0.0022, 2 significant figures in that answer. Okay, so again, like remember, I save these. So this will be posted tonight. It'll be posted along with all the other chapter 3 slides. So it's posted or listed as, if you look at the top, it's the chapter 3 marked up PowerPoint. So it's posted in exam 2 module in Moodle. So if you want to ever go back and look at anything, like versus like watching the lecture video, if you want to do that, you could check these ones. So if you're like practice them yourself, you could always check your answers. Like if you look at the blank ones, because the blank pages have the question, but not the answer. So the marked up ones always have the answer that's there. Okay, where am I? It's here. So where we got last time. So last time we started talking about organic molecules. And so in this, remember that the chain of carbons is traditionally then how they begin to name organic molecules. So I actually just made this chart bigger, like I cropped it, made it bigger and cropped it here so that maybe you could see it a little bit better. So atoms or molecules with 1 to 4 carbons, those have kind of odd names because it's not something that follows like a number version, like how we did mono, di, tri, tetra. These ones don't. So 1 carbon is meth, so methane is a CH4 molecule. 2 is eth, so an ethane is a 2 carbon molecule, so it is a CH3CH2. Or you could think of is that it's got 2 carbons, and then remember carbon has to have 4 bonds. So you can see that there'd be 2 hydrogens above, 2 below, 1 to the left, 1 to the right. So that's where 6 would be distributed. Propane is 3, butane is 4. But once we get past that, and those are really ones to kind of, you got to remember, you just got to kind of practice them to remember them. 1 is methane, 2 is ethane, 3 is propane, 4 is butane. But once you get past that, now they start looking just like geometric shapes, like a pentagon, a hexagon, a heptagon, an octagon. So they really follow more the normal number prefixes, like those Greek prefixes. So this is one that I had. It's a little further on your PowerPoints if you're looking at it. Remember I told you that these are common fuels. So like methane is natural gas, propane is bottled gas or liquid propane, like what you use for a gas grill. Gasoline is a combination of what they call isooctane, nothing but carbons and hydrogens. Diesel fuel is one that's actually even bigger. So diesel doesn't have to be as purified as gasoline does, which like doesn't make any sense to me because diesel costs so much. But part of the reason that diesel costs so much is the amount of taxes on diesel fuel. Because who uses diesel? Truck drivers. And so they have like this big tax on diesel fuel, not because it's more difficult to make, but because of the taxes that they put on it for trucking. Because they say like, since they're traveling on the highways, they should pay a higher tax because they're the ones that are like requiring so much more road work. Whatever. Okay, but now if we go and increase even larger, there's hentriacontane, which is 31 carbons in a chain. So this is like wax, like candle wax. is like a really huge long chain of carbon, okay? So just other examples, because I was telling you that they're used primarily for fuel. Then I told you that there can be ring structures. And really, cyclopentane, cyclohexane, these are really the ones that you would see. Occasionally, maybe cyclooctane. I just have a really hard time drawing a cyclooctane, so I don't usually do that unless I use like the draw thing, because doing an 8-sided figure, mine ends up looking really lopsided and strange. So I typically stick with the one that looks like a little house and the one that looks like a stop sign. I can kind of manage those ones, but when we go much beyond those, then it's a little beyond me. When you have a hydrocarbon, these alkanes, if there's any branches, so like it's pretty easy if you see CH3, CH2, 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 CH3. You just count the number of carbons in the chain, 1, 2, 3, 4, 5, and you go, oh, this is pentane. Okay? 5 carbons in the chain, it's pentane. That's just it. You just know that there's hydrogens above and below and on the ends of that chain molecule. But what if you have this? So what if you have 4 carbons that are in a chain, but then off of one of these carbons is another carbon? So now they're not all in a row. They're not all in one single line. Now I've got a branch. So if there's a branch chain, we have to name the longest chain, and then we also have to name that non-hydrogen group that's hanging off. So the IUPAC, these are the fancy people that decided how to name things. See, International Union of Pure and Applied Chemistry. So they're the ones that make these rules. Some of them sound redundant, I will tell you. It's fine. We just follow the rules because that's the general gist. So here's the steps, okay? So I'll kind of go back to this chart, back to this chart, back to this chart every single time, because we will use this each and every time we do either naming or we draw organic molecules. There's 4 steps. First step, you always find the longest carbon chain in the molecule. That becomes like the last name. So that becomes the end name in the molecule. Make sure that you count from every end possible so you find the longest. The longest chain does not have to be in a row. The longest chain could come across and go down, but it's the longest carbons connected together, okay? So don't think of it as like the longest row of carbons. Think of the longest chain of carbons, not necessarily in a row. Then 2, you would then identify any groups that are hanging off. These are really the only groups we are going to work with. If there's extra carbon groups hanging off, or if there's one of the halogens hanging off. And the reason why we use these ones is because they're pretty straightforward. So if you have a single carbon group hanging off, it'll look like a CH3 sticking off of the main chain. Instead of methane, if it's a group hanging off, they call it a methyl. If it's a 2 carbon group hanging off, they call it, instead of ethane, it now becomes ethyl. So see the YL that is added. This beginning tells you the number of carbons in the group, but the YL tells you that it's connected to the chain. The other 4 are the halogens, fluorine, chlorine, bromine, and iodine. Remember that they're in group 7. Remember that they only form a single bond, right? So none of these do anything except form a single bond. So fluorine, chlorine, bromine, and iodine, you could have them anywhere there could be a hydrogen because they do the same thing. It's just a single bond. So you may find those. If they're present, you name them. You use the first part of the name. Look, I have it misspelled. You have the first part of the name, so fluor, and you just add an O. So fluoro, chloro, bromo, iodo. Those are the ways that you name any of the halogens. Step 3. Step 3, you're going to number the longest carbon chain from the end closest to the hanging group. So literally, you number the carbons 1, 2, 3, 4, 5, 6. If you had a hexane, you would number the carbons in the chain so that you can identify where the non-hydrogen groups are attached. Then you just list them. So they all get listed in front of the parent chain that you figure out in step 1, and you just list them alphabetically. Easiest way to show you how to do this is just to show you a couple of them. So here's one, okay? So in this one, all those little dashes are hydrogens. I just don't have the hydrogens just so that you can like look for the carbons. So how many carbons total in this molecule? 1, 2, 3, 4, 5, 6, 7, 8, 9. Do you see that there's 9? Okay, but I want to find the longest carbon chain. So you start from every end and tell me what is the longest carbon chain in this molecule? 6. Do you see that no matter which direction, if I go like this, do you see 6? Okay, if I go like this, I see 6. Even if I go like this, it's still 6. Okay, so sometimes it'll be more than one, but it'll actually end up being exactly the same name no matter which length you decide. Okay, so we'll just say, okay, since for simplicity's sake, we're going to call this. So 6 carbons in a chain is called a what? What is 6? It's hexane. They're all single bonds. That's why they always end in A-N-E. So these ones are always going to be A-N-E. Okay? So now I've actually named everything I circled. But I have this one sticking up here. That is a single carbon group. So that would be a methyl. And then down here, this is actually a 2 carbon group. So that would be what? Ethyl. So now I've named everything. And I always try to like circle them as I go, because if I circle them as I go, I don't miss them. If I just look at them and count, then a lot of times I end up missing them. So now I've got to do step 3. Step 3, I've got to number the chain closest to a hanging group. So which side? So thinking about this, I'm either going to go 1, 2, 3, 4, 5, 6, right? That would be numbering my hexane from left to right. But I could also go the opposite direction, which would be 1, 2, 3, 4, 5, 6. The rule is you always want to number to give the lowest possible number combination. So always start from an end closest to a hanging group. So which side has a hanging group closer, the right or the left? The right. So do you see that that puts my methyl on carbon 2? So if you count the green numbers, that means this is carbon 2, and the ethyl is carbon 4. So the number in front of methyl tells me which carbon it hangs from. The number in front of ethyl tells me it hangs off of carbon number 4. So then the last thing, I just have to list them all together, but I have to list them alphabetically. So do I write ethyl first or methyl first? Ethyl, because it's an E. So I would write this as 4 ethyl, 2 methyl, hexane. So this tells me I have a 6 carbon chain. Hanging off of the second carbon, I have a methyl. Hanging off of the 4th carbon, I have an ethyl. The number tells you which carbon in the chain that group is attached to. Okay, so try the next one. You see first, tell me the longest carbon chain. Start from every end and count. It's the longest carbon chain. So see, like I could go like this. That would only be 4. I could go like this. That would be 1, 2, 3, 4, 5, 6, 7. Okay. What else? There's actually one more. What can I do? The carbon chain does not have to be in a row. They're just carbons connected. What is the longest number of carbons that I can see connected as a chain? 8. Does anybody see 8? Find 8. Start on this corner. It's 1, 2, 3, 4, 5, 6, 7, 8. So do you see that? So it goes down, around. That's okay. They're connected. So 8 would be a what? Octane. Now, anything above pent is pretty easy. Pentane, hexane, heptane, octane. It's just like a geometric shape. It's just the first 4 that you have to remember. So that means I've now named all of those carbons. Are there anything that's not hydrogen that I have to name? So I took care of those 8 carbons, but what's still there? That one down in the corner? So what is this? It's a single carbon group. That is a methyl. Right? So remember, one carbon is meth. When it's a hanging group, it's methyl. It's the only one, so I know that's going to go right here. But which carbon is it hanging off of? Which way do I start numbering? Do I start numbering from that left or from that little top right side? Top right. Because, see if I go here, this is 1, 2, 3, 4, 5, 6, 7, and 8. That means this methyl is hanging off of carbon number 3. If I went the other way, it would be 1, 2, 3, 4, 5, 6, 6. It would end up being hanging off of carbon 6. That's why I call this 3-methyl octane. All that name means, octane tells you you have 8 carbons in a row, and there's a methyl group hanging off of carbon number 3. Now remember, all these little dashes, those are hydrogens. It just gets very cumbersome trying to add all those hydrogens in. So I just kind of drew like a carbon chain for you just so you can kind of see it in the simple. So now in this next one, we can add in the hydrogens. So see how they look more complicated? They're not really more complicated. All you're looking at is you're really just trying to pick out what is the longest carbon chain, what are any groups outside of that chain, and then number them. Oh, back here. So in this one, longest carbon chain is what? Top left. 4, right? Now you would be fine if you went like this, 1, 2, 3, 4. Okay, you would not be wrong if you went 1, 2, 3, 4. Do you see that that's still the same? Right, it's still a chain. And that's why really you want to kind of like check from all the ends. Check from any ends to see if you can get the longest possible chain. Okay, but for simplicity, we could say it's this. So 4 in a row, that means it's a butane. 1 is methane, 2 is ethane, 3 is propane, 4 is butane. Those are the 4 weird ones you just got to learn. All the hydrogens attached to the butane, you don't have to name those. The only thing you have to name is non-hydrogen group. So what is that? So this is a what? It's a single carbon group. So this is a methyl. So a methyl is a CH3 group that's hanging off of the chain. So I know that this is methyl butane. The only thing I have to do last is I have to indicate where is the methyl on the chain. So the methyl would be on carbon number what? 2. Does everybody see why? I'd start numbering from the right because that would give me 2-methyl. If I numbered from the left, it would be a 3. So I'd number from the right, so this would be carbon 1, carbon 2. That's why this is 2-methyl butane. So what if I have more than one non-hydrogen group? So let's look at the one over to the right. You tell me, what is the longest carbon chain? Okay, yeah, 6, good. Did everybody catch this? See that that's 6? If I had just gone straight across, it would have been 5. Right? So going down is actually a longer chain of carbons. So 6 makes this a hexane. And now I have to name this. So what's that? It's a methyl. Anything else? See this. Ooh. This is a chloro. So now I got a number. Which side am I going to number? From that left or from the bottom? Because? Yep, so if I number from this side, 1, 2, 3, 4, 5, 6. See that chloro would be a 1? If I number from the other side, chloro would be a 6. You always want the lowest possible number. So that tells you which side to start numbering from. So that means chloro gets a 1 because it's hanging off of carbon 1. Methyl gets a 4. So see, carbon 4 is what it's hanging off of. So that's carbon 4. Last step is to put these alphabetical. So it would be 1 chloro, 4 methyl, hexane. So the number in front of each of the hanging groups tells you which carbon it's attached to. This one has 3. So find the longest carbon chain. Tell me how many. How many do you see? 7. So 1, 2, 3, 4, 5, 6, 7 is straight across. Now, if you did this, do you see that's also 7? That wouldn't change your answer though. Okay, so either one would be fine. So 7 makes this a heptane. That becomes the last word. Now I've got to find anything that's not hydrogen that's hanging off. So where do you see one? You got a what? A methyl. So right here, do you see the methyl? And this is an ethyl, yeah. So see how that's 2 carbons hanging off of 1? That's an ethyl. One more. So you call this a bromo, right? So chlorine is chloro, bromine is bromo, fluorine is fluoro, and iodine is iodo. You just use the first part plus an O. Which side do I number? Right to left? Left to right. From the which? So like if you look and you go in, which side do you get to the first hanging group? From the left or the right? From the left. So if I start from the left, see 2 in, and there's a hanging group. If I start from the right, I go in 3 before I get to a hanging group. So I want to start numbering from the left because that'll give me the lowest number combination. So this is 1, 2, 3, 4, 5, 6, 7. So I number the hexane, the heptane. So now my methyl is a 2 because it's hanging off of carbon 2. My bromo is a 3, not a 2. My bromo is a 3, and my ethyl is a 5. So that number is just telling me which carbon it's hanging off of. Last thing to do, though, before you write this, is you put them what? Alphabetical. So which do you put first? Yep, so 3 bromo, then 5 ethyl, and then, okay, so you don't list it by number, which seems like that would be better, but I didn't make the rules. You list them alphabetically. So these are Lewis structures, right? So these have all of the bonds. It shows all the hydrogens, everything's there. So what happens if it's a skeletal structure? So remember, we talked about skeletal structure or mentioned them. What do you remember about a skeletal structure? So for this first one, the little zigzag with the chlorine on it. The thing to remember, every corner and every end, unless it's attached to a halogen, is a carbon. So in this molecule, this is a carbon, 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 and that one is. But the one at the end where the chlorine is, there's not a carbon on the end. That represents the bond to the chlorine. So for a skeletal structure, every corner and every end is a carbon unless it's attaching to a halogen. So chlorine, fluorine, bromine, iodine, at the end of that line is the halogen. So what's that long chain? This is a what? Hexane. Right? 6 carbons in the chain. Notice that there's no options. It's really just those 6 in a chain. But this is a fluoro. And then which side would I number from? Left or right? Left. Good. So this would be carbon 1, carbon 2, 3, 4, 5, and 6. So my chloro is on carbon number 2. So this is 2 chlorohexane. Now the one to the right of it, there's no halogens. It's just sticks, right? It's just lines. And so what I do is I always go in and put them in because I find it's easier for me to figure out the longest carbon chain, etc. So I just go in and go carbon, 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 carbon. In this case, those on the middle, any ones in the corner, any on an end, all those are carbons. So what's the longest carbon chain? No, more than that. Nope, longer than that. I didn't get that many. What'd you get? I think I heard it. 7. Good. Do you see this? These are all carbons in a chain. Okay? And if you count 1, 2, 3, 4, 5, 6, 7. So that makes this a, boy, my pen's acting crazy. That makes this a heptane. So I've named everything I've circled, which is one of the reasons I like to circle the longest carbon chain. So I've circled everything, or let's do this one. But now see, I've got these ones sticking up here, here, and here. What are those? It just looks like a line sticking off, but what is that? If it's a C, remember it's going to have 3 hydrogens on it because carbon has to have 4 bonds. So this represents CH3, which is a what? So what's a CH3 group? A single carbon. What's a CH3? Go back. CH3s? Methyls. So CH3, this is a methyl. But then what about this one? That's a methyl too. And this one? That's also a methyl. So I have 3 methyls. So instead of saying methyl, 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 they let you put them together, but you have to use the Greek prefix. So if I have 3, you call it what? Tri. This would be trimethyl. But I do have to put the carbons they hang off of. So which side of that green chain do I start from? The right or the left? Do I start numbering from the left? That'd be 1, 2, 3, 4, 5, 6, 7, right? Because that's the heptane. That means I'd have a 4, 5, and 6. But what if I numbered from the other side? If I numbered from the other side, then that would give me, no, I can't use that color. Then that would give me 1, 2, 3, 4, 5, 6, and 7. So then that would give me a methyl on 2, a methyl on 3, and a methyl on 4. So do you see that the orange numbers from right to left are lower? That would give me that this would be a 2, this would be a 3, and this one would be a 4. So that would actually give me a lower combination than if I started numbering from the left. So I just list those in order. 2, 3, 4, trimethyl heptane. So what this means is this is a 7-carbon chain. That's the heptane. So I put 7 carbons in the chain. I'd have a methyl off of carbon 2, a methyl off of carbon 3, and a methyl off of carbon 4. So that's what the number, it's kind of like puts it in order. So you're going to number the chain, right? So the green is the chain. That's where I got heptane, right? So I've got to number that longest chain, and you always just number from the side to give you the lowest number on the hanging groups. So I don't just number left to right. I have to look at both sides. And so if you look, do you see where I numbered it in red? 1, 2, 3, 4, 5, 6, 7. So do you see that would put a methyl on 4, 5, and 6? That's bigger, higher numbers than 2, 3, 4. So that's why I would actually number from the right and go left, because it would give me the lowest possible number combinations. So I'll tell you, this one is one that people make a mistake all the time. So I want you to add your dots to indicate where are the carbons. Tell me then, how many carbons in total? How many do you see? This bottom left one. Five? Nope, more than that. There's 6. Okay, so this is a carbon. Everybody's got that, right? This is a carbon. 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 Okay, but remember the ones going to the chlorine? That's just the bond going to the chlorine. So there isn't a carbon at the end of that line. There's a chlorine at the end of that line. So if there's 6, that means this is a hexane, right? So I just named this. So this is a chloro, and this is a chloro. So I have 2 of them. So this would make this a, like this was a trimethyl, so this would be a, not tri is 3, so 2 would be di. So this is a dichlorohexane. Oh, that looks like a funny D there. So I have that, and that way I don't have to have chloro, I can put the chloros together. So last thing I've got to do is I've got a number. So now, do I number from the left or the right? I'm going to number from the right. You see the chlorine, first chlorine is on carbon number 1. So this would be carbon 1, carbon 2, carbon 3, 4, 5, and 6. So that means I have a chlorine off of carbon 1 and a chlorine off of carbon 2. So I would just put 1, 2 dichlorohexane. Right? If there's a cyclo, if you have a ring, remember the cyclopentane, cyclohexane, those pretty much those 2. If you have a cyclo, then the ring is the longest carbon chain. So you just name it by how many carbons in the ring. So if it's a ring of 5, it's a pentane. Ring of 6 is a hexane, but you put the word cyclo in front of it. So like here, so for this one, how many carbons in the ring, for the red one? I changed this, I rewrote this one so that it would make a little more sense. So, but that one's on there. Do you see it? So how many carbons in this ring? So when I name, first thing you do is you name the ring, and that means this is a cyclo because it's a ring, and then it's 6, so it's a hexane. Okay? So the ring of 6 is a cyclohexane, and that takes care of all of that. If you see the word cyclo, you know you got to make a ring. Okay? Or if you see a structure with the ring, you know it's a cyclo. And you're going to name, the last name is the size of the ring. Then I just name anything that's not hydrogen that's hanging off of my ring. So that CH2, CH3, that's a what? 2 carbon group. Ethyl. That's a 2 carbon group because it's a CH2, CH3. So it's hanging off of the ring just by like one connection. So that's an ethyl. And if there's only one hanging group, you really don't have to name it. But if I was gonna, or number it, but if I was gonna number it, which would I put it as? 1, because you want it to be the lowest, right? So I would just start numbering here. It would be 1. It wouldn't matter if I went clockwise or counterclockwise, it would still be 1. Because that would give ethyl the lowest number possible. No, you wouldn't. The book, in fact, like traditionally, if there's only one, it's kind of like mono in front of a single element. You don't put it. You wouldn't have to, but if you put the 1, I wouldn't have a problem with it. In fact, your book likes you to put these little dashes and commas, and they're very particular about that, but I don't care. If you just do the name, I'm all okay. Okay? Put them alphabetically, find the longest carbon chain, name the hanging groups, number the chain, and then put them alphabetically. That's fine by me. So what's the one to the right? So that one you would have to draw because that one's a new one. It's not on your PowerPoint because I changed this PowerPoint just to put more cyclos on it because I was like, there's only one cyclo here. What am I doing? So what is that one? This would be a what? Huh? Yes. So this is a cyclopentane. Ring of 5. Can you count 5? It looks like a little house. Okay, so now I've taken care of this. By naming the ring of 5, I've taken care of all those carbons in the ring. So I just have to name anything that's hanging off of the ring that's not hydrogen. So do you see anything? Okay, where? Up at the top. And down at the bottom. Good. But see, all the others are hydrogen. I don't have to name the hydrogens. They're assumed. They're part of the cyclopentane. I only have to name non-hydrogen groups. So this chlorine becomes a chloro. And this chlorine becomes a chloro. And since I have 2 of them, they're called dichloro. Now, the fun of the numbering. How do you number this? Where will I start? Okay, you got to start at the chlorine. Okay, you're going to start on the carbon that has a chlorine because that'll be a 1. And that's always going to give you the lowest number combination. Which direction would I go? So if I start up here, do you see that 1, 2, 3 puts the chlorine on carbon 3? If I went the other way, the chlorine would be on carbon 4. So if I went clockwise, it would put me at carbon 3. So then this is 1, 3. If I went the other direction, it would be 1, 4. So you would want to try and get the lowest. And now, even if you started your numbering here, if I made this one, I was like, no, I want to count. You're always going to start where there's a non-hydrogen group. But if I counted back this direction, do you see it's the exact same? So it'd be 1, 3. Either direction, it still would be 1, 3. So see, I told you I can't draw this one unless I use the shape draw. So what's that? Yes. And if you see this, it would only be a shape draw. I can't draw it. I was trying. I was like, no, that doesn't look like it. No, that doesn't look like it. And maybe that looks like a stop sign. Does the stop sign look like that, or is the stop sign a hexane? A cyclo? Huh? That's a cyclo. I don't know how to take my driver's test for a while, so I'm okay. Okay, so that's a cyclo, right? Is it? Yes? Okay, so now you tell me what's this. Remember when I named cyclooctane, that names all of this. But what's that? What's a stick just sticking off? It's a carbon. So that means this is a single carbon is a methyl. And there's another one, right? It looks like a little duck beak. Okay, so that one is a methyl as well. So there, two methyls means it's a dimethyl. And which carbon would it be on? Carbon 1. So you could have 1, 1, or you could just call it dimethyl cyclooctane because that would say they're both on 1. Either way would be fine. Okay, so that shows kind of like condensed structural, shows a Lewis structure, shows a skeletal structure with the cyclo. So now let's do the naming, or the drawing from the naming. So now, if I give you a name, draw this. Here's the steps. I think this is easier, not gonna lie. Okay, I think it's easier to draw it from the name. What are you gonna start with? Hexane, right? So you always look at the last word. So the last word tells you the longest carbon chain. And now you get to put it in the nice straight left to right. So this first one is hexane. So I'm going to draw 1, 2, 3, 4, 5, 6. Right? And so if you wanted to do a Lewis structure, you would have to put bonds up, down, above and below every carbon and on the ends. Then number 2, you're going to number the chain. So you could number it any way that you want. I number left to right because it seems like that's like the normal order of life, right? So then I would just say, okay, well, that's carbon 1, 2, 3, 4, 5, and 6. Then the third thing, you just add the hanging groups based on the name. So 2-methyl tells you what? There's a carbon sticking off of carbon number 2. I just drop it down a little lower so it's easier to draw. But you see that's a CH3 hanging off of carbon 2. You could put it above. That would be fine too. Or you could put it below. Doesn't really matter. But that's 2-methyl. So then where's 3-chloro? Yep, so put a chlorine off of carbon number 3. You could put it above, you could put it below. As long as it's attached to carbon number 3, it's correct. Anything else? Nope. Right? So you've named it. That's it. You're done. All of these, if you were doing true Lewis structure, which is so annoying, just because of all these hydrogens, all these little blank dashes, remember carbon has to have 4 bonds, so all the rest of those empty dashes are hydrogens. Now I could take this and I could simplify this and put a condensed structural formula. So you tell me, what would a condensed structural formula look like? So the condensed lists each carbon and what is around it. So the first carbon would be a what? CH3. And then the second carbon has how many hydrogens? Just 1. So it would be CH, and then I'd have a line down to a CH3. So you see that? Third carbon would have how many hydrogens? 1, CH, and then would have a line up to a Cl. And then carbon 4 would be a CH2, carbon 5, CH2, carbon 6. CH3. You see those? So that they call it condensed. It tells you every carbon, you put like what's around it. If there's a hanging group, put it up or below, right? So if there's a hanging group that's not part of the chain, lift it or drop it and just connect it by a line. I think it's easier to see Can you like see the hanging group better that way? This is just like, whatever's easier for you. You could even do this as a skeletal structure. So if I was going to draw a hexane as a skeletal structure, how many lines would I draw? 5. Because it's always one less than the number of carbons. Because skeletal just shows you the links between carbon atoms. So you could do it a couple of ways. You could just say hexane has 6 carbons, so I need 5 in my zigzag. Or you could put your pen down and that's 1. Where your pen starts, so this would be 1, 2, 3, 4, 5, 6. Okay? So you could do it that way. And if you count back 1, 2, 3, 4, 5, 6, can you see there's six corners or ends? So that's a hexane. Now, number 2, I would still number the chain. I mean, now if you can remember, okay, well, I'm just going to hang a methyl off of 2 and a chloro off of 3, you're good. But you could also go back and number this. So this would be 1, 2, 3, 4, 5, 6. So there's the carbons in the chain. So if I want to make a methyl on a skeletal structure, what's it going to look like? A methyl. So what does a methyl look like in a skeletal structure? It's just a line, right? So I just need a line coming off of carbon 2. That's a methyl. It just looks like a stick. It just looks like a line sticking off. But remember, at that end is a carbon, so it's a CH3. So then I need to put a chlorine off of carbon number 3. So how will I do that? Come down and a CO. Okay, so I thought I'd draw all 3 of them just so that you can kind of see the difference. Not a bad idea just to practice, even looking back at the ones we've done and kind of practice drawing the different ones on the exam. It's your choice. I will say, draw the structure with this name. You can draw a skeletal, you can draw a Lewis structure, you could draw a condensed. Doesn't matter. One of those 3 is what you're really going to need. Can't do a molecular formula because that doesn't tell me anything about bonding. But this really shows me like the bonding. Okay, so try this one. So it's decane. What do you got to do? Yeah, you got to put 10. Hold on, I lost my ability to change colors again. Come back. Okay, so how many? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember that this means carbon has 4 single bonds. That means that there is a bond above, below, and on the ends. That doesn't look like it's attached. There. Okay? So that's my longest carbon chain. You just look at the last word. That tells you how long. Decane is 10. Then I number. You're just going to number from left to right. I think that's probably the easiest thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Ooh, you can't hardly see that. Then, what am I going to add? Fluorine where? Add a fluorine on 3 and a fluorine on 4. F and F. Remember, fluorine is F, not FL. Right? So see, carbon 3, carbon 4, each got fluorines because it's difluoro. So I know that means 2. And then what's 7-ethyl? What do I have to do? What is an ethyl? It's a 2 carbons. So that means that it's a C. If I was going to draw Lewis structures, those would all have H's. Right? So is that it? Yep. So all of these are hydrogens. All the dashes that don't have anything, those are hydrogens. That's the Lewis structure. Okay? Lewis structure shows all the dashes. Everything is spread out. You're showing all the bonding. But condensed, what would it look like if we were going to do condensed? So what would carbon 1 look like? CH3. Carbon 2? CH2. Carbon 3? C with an H, right? Because you see there's one hydrogen on carbon 3. So it would be CH, and then you would have F coming off. Carbon 4, CH with another F hanging off. Carbon 5, CH2, 6, CH2, 7, CH, and coming down would be a CH2, CH3. Do you see that's an ethyl? Right? So any hanging groups, just drop them below, or you could put them above. It would be fine. But just use the line to like connect them to your chain. So do you understand why that only has a CH, not a CH2? Right? So it has one hydrogen because the ethyl group takes up its fourth bond. Now, continuing on, 8 and 9 are both CH2s, and 10, CH3. That's a condensed structural formula. It just tells you what, after every carbon, those are what's around that carbon. So CH3 means a carbon with 3 hydrogens. CH2, a carbon with 2 hydrogens. All those carbons are linked, okay? Zigzag, skeletal structure, how many lines? 9, right? So if I put my pen down, where I put it down, that's carbon number 1. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See how easy that is? Especially when it's big, when you got 10 carbons, like done, there, 10 carbons, okay? Then I would tell you to, I would caution you to still number them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, it'll make sure that you put the right number down, right? It is a way to check yourself, and you always start on the end, and you should end on an end, right? Because those ends are carbons. Then, off of carbon 3 and 4, you're going to hang a, just going to hang a fluoro here, and a fluoro here, and off of carbon number 7, you'd have a bent line. A line with the bend, because that would be 2 carbons. Just a single one would be a methyl, but see how that comes down in an angle? That bend is a carbon, and the end of it is a carbon, so that's an ethyl group. Okay, so that's why I think that it's actually easier to draw these, but just do the steps. Put down your longest chain first, however you decide to draw it, then put down your, number the chain, add the hanging groups. If you do a Lewis structure, you got to go back and add all those hydrogens. Okay, so try these. 3-ethylhexane, 1-bromo-3-iodocyclopentane, and 1,2-dichloropropane. This will be the last, just to practice. So if I see hexane, what am I going to put? 6. And then 3-ethyl, so what's that going to be? And how many? Off of carbon number 3, the third one from the left, I'm going to hang an ethyl. And an ethyl is what? Is it 1 carbon? It's 2. So I got to have 2. Right? So that's kind of like, this is the map of how you're going to do it. Now it just depends on which way you want to do it. Right? Do you want to do a Lewis structure? You got to add all the lines and all the hydrogens. You want to do the condensed? You can now go to the condensed from this. If you want to do skeletal, you can now change this into the zigzags, either one. Because see, I'm done. I've listed the whole thing, 3-ethylhexane. So that means that this carbon is now a CH3, CH2, CH, and then a CH2, CH3 hanging down. Then I have a CH2 coming across, CH2, and the last one's a CH3. Did you see that? So just kind of like, you may want to just kind of do like the rough of what it's going to look like, put everything down, and then you could just continue, you could fit it however. If I was going to do the zigzag, 1, 2, 3, 4, 5, 1, 2, 3, yeah, 6, 5 lines, and then off of, you'd start, the end is 1, up is 2, down is 3, so this would come off and go that way. So that would be the skeletal for that one. 1-bromo-3-iodocyclopentane. How do I draw that? What do I got to draw first? It's pentagon, right? Because you see cyclo. When you see cyclo, you know you got to put a ring in. So I would do the rough, just do the outline of what the carbons would be. So a cyclopentane is a ring of 5 carbons. Don't put anything else on until you put the others in. So what am I going to have to hang off of this? And where are you going to put it? Okay, put it up at the top. So that's a bromo, and we're going to call that then carbon number 1, right? So then, where am I going to put the iodine? So that means number. And you can number however you want. You could go counterclockwise. You could just be like the clock. You can go clockwise. Like we're kind of creatures of habit. So then carbon 3 would be the iodine. Okay, so that carbon 1, how many hydrogens does carbon 1 have to have? Remember, it has to have 4 bonds. How many do you see? 3. So this means this has to have 1 more hydrogen. Do you understand? That carbon number 1, all carbons have to have 4 bonds. So you see 1 is to the bromine, 2 are to 2 carbons. So there must be another hydrogen there. Okay, so even if you don't see it, remember that it's you'd have to add. So this carbon number 2 would have to have what? How many hydrogens? Well, not 4 hydrogens, it's got to have 4 bonds, so that means it's got to have 2. Do you see now that carbon has 4? So carbon 3 with the iodine, that one has 1, because it'll get 4. The 4 and 5 each have what? How many hydrogens? They'd each have 2. So I kind of wanted just to show you that part, right? So remember, in the ring, every carbon is going to have 2 bonds, 1 to each carbon in the ring. So it's always going to have 2 other things connected. If you don't have a hanging group, it's got to be hydrogens. So if I was going to do the skeletal structure, it would just look like a little house. That's the ring of 5. Then I'd have a Br sticking up and an I coming off of 3. If you wanted to do it in the condensed, you can still do that. That would be CH, CH2, CH, CH2, CH2 back, and then Br up and I off of 3. Can you see those? So it just depends on how you actually want it drawn. Okay? All right, so